theorized that we are no further than 6 degrees of separation from any stranger in the entire world, where a decision made in one country may have drastic effects on another. We must contemplate the implications of this connectedness.
This globalization is made possible by the immense amount of technological infrastructure the New World has created. However, another unlikely suspect unites us as human as well: disease.
Almost all of us are vulnerable to the same infection and viruses. We contain the same internal systems and are affected by disease in the same ways.
Our connectedness through disease is so powerful that we must wonder, how, in a globalized world, do we combat illness? In this study, we examined 3 articles related to the globalization of H1N1.
The first article is called The H1N1 Influenza Pandemic of 2009.
The second article is assessing vaccine efficacy in influenza clinical trials, challenges and difficulties.
The third is titled The New Global Health.
Have you ever had a cough, a fever, a sore throat, a runny nose, body ache, headache, chill, or fatigue? I'm not talking about any old common cough, fever, sore throat, runny nose, body ache, headache, chill, or fatigue. I'm talking about H1N1, the deadly, lethal H1N1 virus. Did I mention to you that it's deadly? 'Cause it is.
But Nick, how deadly is it?
Girl, I'm half dead just thinking about it. Nah, I'm just kidding.
Now, Brianna, we know these things may sound very scary right now, but you as an individual, your country, and the people around you take many measures and procedures to make sure that you don't contract these diseases. Today, we will be examining 3 preventative measures against the globalization of the plague. First, how your government does it through biosecurity. Second, how you as an individual can do it through vaccines. And thirdly, the effect that global health standards have on disease circulation.
But Lenny, aren't we getting a little too far ahead of ourselves?
Yeah, Lenny. I mean, I don't even think any of these kids know what H1N1 means. Why don't we take a look at it?
So, you may ask yourself, where does the swine flu, also known as H1N1, really come from? In truth, it turns out that the 2009 H1N1 outbreak that we experienced began circulating in pigs as far back as 1918. Now, around the same time in 1918, the influenza virus was also wreaking havoc on humans in European nations. Because these diseases were different and originated in different hosts, they evolved differently, and pigs develop an immunity to H1N1 while humans work to develop an immunity towards their common influenza. As that swine flu evolved in pigs, it developed capabilities to infiltrate the human immune system, and now basically has become a new virus altogether. So, what other animals carry H1N1? Well, both whales and seals carry particular strains of H1N1, and horses are also known to carry the virus. Recently, dogs have also become a host for the influenza strain. You may ask yourself, what does this virus look like anyway? Well, here we have Andrew Picaz, an associate professor of molecular biology at Johns Hopkins, to break it down for us.
An influenza virus particle is roughly round in shape. It has a couple of protrusions coming off of it in 2 different shapes. One that's more of a spike and one more of a propeller shape. The H spike is used to enter a cell, and the other, the N spike that we always refer to, is used to actually get away from a cell. Anywhere from 9 to 12 hours later, the surface of that cell starts to form little bubbles, and those bubbles are new virus particles coming off. For about 3 to 4 hours, that cell will be able to make infectious virus particles, and it can make anywhere from 10,000 to nearly 1 million virus particles depending on the cell type.
Thanks, Andrew. Finally, as we know, there are some individuals who are immune to the H1 influenza strain, so how does that work? Well, basically, this means that you have antibodies that can bind to the virus and simply ensure that the virus doesn't reproduce and enter your bloodstream.
All that info came at you real fast. Now, let's take a look at what your country is doing to keep you safe.
Now, to begin our analysis, I chose an article called The H1N1 Influenza Pandemic of 2009 in order to discuss biosecurity. The editor is Charles Bartolotti, but the article consists of different chapters written by different authors. The main article that I used was written by Lawrence Kapp, who specializes in military manpower policy, and Don J. Jansen, who specializes in defense healthcare policy.
Well, what is biosecurity anyway?
There are two different definitions for the word biosecurity. The first is a more modern definition that connects biosecurity with the use of biological weapons in an effort to counteract terrorism. The second is the meaning that will be used during this video. This one includes protection from security threats, such as diseases and viruses. So one of the first things that the United States government does when an epidemic hits U.S. soil is contact the Department of Defense, aka the DoD. The DoD has four main tasks. These include assisting in disease surveillance, assisting partner nations, protecting U.S. forces, and providing support to civil authorities. Oh, you snuck up on me. The first thing that the DoD did in 2009 was make sure that the military and government leaders were protected from the virus. Because there was no vaccine at the time, the DoD made sure that there was plenty of Tamiflu and Relenza on hand to support our government leaders. In my scholarly article, Don Jansen writes, an influenza pandemic could conceivably render naval ships unable to perform missions, shut down training and support activities on major bases, seriously degrade security at critical sites, and break the supply chain that sustains forward deployed services. If military and government leaders are not taken care of right away, the U.S. could possibly become susceptible to terrorism. And that's a terrible thing.
During the outbreak of H1N1, the DoD worked to ensure that American forces can remain operating at the highest levels of security. When onslaughts of diseases like H1N1 come stateside, it's a priority of our government to ensure that our forces aren't vulnerable.
The article that I analyzed is by Walter Dew, Anna Benoit, and Catherine LeGrand, who are all scientific statisticians.
This article is very different than mine, in that it centers more around statistics.
Dew, Benoit, and LeGrand carried out the VE, aka vaccine efficacy trials, which is an assessment of the phase 3 trial where people are enrolled and are randomized to receive the experimental vaccine just before flu season. The statistician carried out the methodology, and throughout the article, they stated they were doing a double-blind influenza test. During the two,
Okay, read half of it.
and then go somewhere.
Chill, yeah.
Yeah.
During the two influenza seasons, subjects received samples by swabbing their mouths to ensure that they had the virus. When testing the vaccines, they used a real vaccine that was intended to prevent the disease. Then they used a control that was either a placebo or an active vaccine with or without an established efficacy against the flu.